Hi everyone. So I know that section 4.2 was a bit complicated, and so I just in this video I just want to explain what do you really need to know from section 4.2, because that whole business with the summation to find the area, to find the exact area, I should say, by using the definition of the sigma notation, is it's not something I would ever ask on a test, right? It's just too crazy of a question, but it's good to see, but it's not something you absolutely need. So what do you need to know, right? Well, you need to know this sigma notation, right? You need to know what this symbol is and what it means, and then how to use it, right? So let's just do a quick example of that. Right, suppose you want to calculate, let's say, the sum, right? Let's say I goes from 2 to 103 of, let's just do 2i squared minus 3. Okay, so how would we calculate this? Well, before we do that, let's just write out what this means, right? In other words, let's do the first couple of terms here, right? So this is the same thing as saying, well, so I is the variable. I starts at 2, so this is 2 times 2 squared minus 3, right? So that's for I equals 2. And then plus, right? So remember, this is a summation, so we're adding. Now what happens when I is 3? Well, it's 2 times 3 squared. Ooh, I should put the 2 on the inside, although it doesn't matter here. 2 times 3 squared minus 3. So that's when I is 3. And then when I is 4, well, it's 2 times 4 squared minus 3. So you get the idea, right? You just keep going. I is 5, 6, 7, 8, 9, 10, all the way up to when I is 103. So you get 2 times 103 squared minus 3. Okay. So that's literally what this symbol represents, right? And it's a much more concise way to write this whole thing here, right? So right, so now how do we calculate it? Well, you're not going to do it one by one, right? Because there's just too many terms and it would take way too long. So what we're going to use is the following. Let me write it way down here, right? So if I starts at 1 and goes to n, then I squared, the sum of the squares of the integers from I going from 1 to n, is given by this formula, n times n plus 1 times 2n plus 1 divided by 6. So that was in the video, the first video for the part 1 for section 4.2, right? And so we're going to use that to calculate this, right? And so the way we're going to do it is we're going to pull out the 2, right? So we're going to split this up as 2, times the sum. I goes from 2 to 103 of I squared, and then minus the sum. I goes from 2 to 103 of the number 3, right? So 3 is just a constant, right? Okay. So, right. So now let's concentrate on this right here. How do I calculate that? Well, I'm going to use this formula, right? Now, there's one issue, of course. This starts at 2, whereas in the formula, you have to start at 1. But that's not really an issue, because if you start at 1, you're just including when I is 1, right? So what's 1 squared? It's just 1, right? So, right, so this would be, 1 squared plus 2 squared plus 3 squared up to n squared. So just leave off the 1, right? In other words, just take away 1 from what I have boxed here in this, right? So, all right, so I'm clearly running out of space here. Let me calculate this down here. So we have 2 And then plug in n is the top number, right? So n in this case is 103, right? So we're going to have n, which is 103, times 103 plus 1 is 104. And then 2 times 103 is 206, but plus 1 is 207, right? And then divide by 6, right? Okay, so that's what I circled in red up here. That's all of this. Make sense? Yep, so that's this. Okay. Oh, yeah, I forgot to subtract 1. Oops. Okay, hang on. I forgot to subtract 1. So take away 1. There we go. Oh, but you're still multiplying it by 2, right? So there's parentheses around all that. So you're actually subtracting 2 times 1. Okay, right. And then, right, so now we have to calculate this up here in the upper right. So we're going from I equals 2 to 103 of, you're just adding up a bunch of 3's, right? So you can think of this as 3 plus 3 plus 3 plus 3, right? Plus 3. And how many of these do we have? Well, we don't have 103, right? Because we're starting at 2. So we have one less than that. We have 102, right? So what we're going to do down here then is take away, because this is a minus, right? 102 times the number 3, right? Because you're adding up a bunch of 3's, 102 of them. So that's just 102 times 3, right? So I hope that's clear, right? Okay, so now we should be able to get the answer here. This is really just a calculator problem. So I'm going to plug that in and see what we get. Okay, so it looks like you have the 2 on the outside. So what's in the brackets here looks to be 369,000. 564. Hope I got that right. And then minus 1, right? And then minus, well, 3 times 102 is 306, I think. Right? Oh, that doesn't go with the 2 here, right? Okay. So, yes. So bracket here, parentheses here, and then minus 306. All right, so obviously 369,564 minus 1 is 369,563, right? And then when you multiply that times 2, you get, sorry, not 2, 739,126. And then minus the 306, which gives us 738,820. Okay, so yep, I know we did problems like this before, but this is what you absolutely should know from 4.2. The other thing is just how to calculate the area of a bunch of rectangles, right? So I guess I'm going to do that here, right? So scroll down a little. So I graph the function f of x equals 4x squared minus x cubed. And we want to we're going to approximate the area under the curve by just adding up the areas of these 3 rectangles. There's actually 4 here. This one, of course, is height 0. So what are the areas of these rectangles, right? So we're going from, so this is the area here, right? Under the function, or under the graph of the function, f of x equals 4x squared minus x cubed, right? And we're going from 0 to 4, right? From x equals 0 to x equals 4, right? And so so what I did is I set my delta x equal to 1, and there's four rectangles, right? So 4 minus 0 divided by 4 is 1, right? So 4 minus 0 divided by 4, right? In other words, this is the b minus a divided by the number of rectangles you want. So b is 4, a is 0, and n, well, I decided on 4 rectangles here. Right. You can do more. You can do 8 or 10 or 100, but then it gets to be rather tedious, as you know. All right. So we know the widths of the rectangles are 1. What about the heights? So there's 4 rectangles. I'll just call them. Well, what should I call them? 1, 2, 3, and 4. Use Roman numerals here so we don't get too confused, right? And the first rectangle is, so I'm using the left-hand endpoints. So these are left-hand endpoints. You could also use the right, but you might get a different answer, I think. So the height of the first, right, the height of rectangle 1 is just f of 0, which is, well, you can calculate that to be 0. So the height is 0, right? What about the height of the second rectangle? It's going to be f of 1, which is 4 times 1 squared minus 1 cubed, just plugging into the given function, right? This way up here. So you get 4 minus 1 is 3, right? What about the height of the third rectangle? Oops. Well, that's going to be f of 2. You can see that here, right? That's f of 2. And it looks to be 8, but let's just verify that, right? This is 4 times 2 squared minus 2 cubed. So 4 times 4 is 16, minus 2 cubed is 8. 16 minus 8 is 8. So, yep, I was right. And then finally, for the fourth rectangle, sorry, it's supposed to be a V here. There we go. Height of the fourth rectangle will be f of 3. So 4 times 3 squared minus 3 cubed. So 9 times 4 is 36 minus 27. I think that's 9. That looks about right there. Right, so those are the heights, and if the widths are all 1, you're really just adding up these numbers, right? So remember this, you're going f of ci times delta x. In this case, I goes from 1 to 4. And so, yep, so this is just f of 0 times delta x, which is 1, plus f of 1 times 1, plus f of 2 times 2, times 1, I'm sorry, plus f of 3 times 1. In other words, it's just, right, f of 0 plus f of 1, plus f of 2, plus f of 3. What made this easy is that just the fact that the width is 1. Right, when delta x is something else, like 1/2, or 3, or 2.5, then you're multiplying all these by that delta x, right? So this is 0 plus 3 plus 8 plus 9. So I guess that's 20. So that's the area of the basically these 3 rectangles. And so it's a very poor approximation to the area under the curve, because as we saw last time, you're missing all this area in here that doesn't get counted, right? So it looks like, well, it looks like the 20 is a little bit lower than what it should be. On the other hand, maybe not, because this 20 also includes all of this area in here, which is actually above the curve, so we don't want to count that. Oops. Didn't mean to do that. Yeah. This area in here is counted when it shouldn't be. And now you have to decide, well, is the red area bigger than the purple area? I don't know. It does look about the same, so maybe 20 is not far off. But it is an approximation to the area under the curve. Okay. So I think that's it. Basically, 2 things you need to know from 4.2, right? You need to know this notation and practically how to calculate things like this. And again, don't worry about the formulas here. You don't have to memorize those. You just have to be able to use them like I did here. And then just calculate the areas of a bunch of rectangles, right? And by a bunch, I mean, four or five, not 12 or 20 or 100, but, a few, right? So maybe up to 5 or 6, but that's about it, right? And so you should have done this hopefully in the homework. But that's about it, right? The business of finding the exact area by using a limit, right? So remember we talked about the limit as n goes to infinity of the sum. I goes from 1 to n, although you could also start at 0 here, right? It depends on which way you have this arranged. Right? F of ci times delta x, and we laborious, right, in a very tedious way calculated all this, and it took up probably almost an hour. So that you don't have to know. So I hope that helps.